In this video, I would like to introduce rational expressions, discuss their domains, and talk about evaluating rational functions. So a rational expression involves a fraction. It's any expression of the form p over q where the numerator and the denominator, p and q, are polynomials, and q is not equal to 0. That polynomial in the denominator cannot equal 0 because division by 0 is undefined in algebra. So here's a couple examples behind me on the board. Notice that the denominator or the numerator does not have to be a binomial or a trinomial. It could be a single term, a monomial. That's also a polynomial and therefore makes these rational expressions. So I said division by 0 is undefined. That gives us a clue into the domain of rational expressions. The domain of a rational expression excludes any value that would make the denominator equal to 0. So when we're talking about what x values can you input into this expression, or if it's written in function form into this function, it's any value that would not make the denominator equal 0. I'll use that fact to find the domain or to find the limits of the domain on rational expressions. So if I'm supposed to find the domain of x minus 3 over 2x plus 5, I'll focus in on this denominator, 2x plus 5. Let's set that equal to 0 and notice what value of x would give us 2x plus 5 equals 0. We find that by solving this equation. So I subtract 5 and I get 2x equals negative 5. And I divide by 2 and I get x equals negative 5 halves. So what we've just seen here is that if x equals negative 5 halves, then this entire denominator equals 0. That's what we don't want to happen. All right, so this is not the only value allowed in the domain. This is the x value that is not allowed in the domain. The domain is everything else except this value. To write that in interval notation, I would say that the domain is from negative infinity all the way up to negative 5 halves. This means anything less than negative 5 halves. Union from 5 halves to positive infinity. This means anything greater than 5 halves. But because I wrote a parentheses around this negative 5 halves, I'm excluding that from the domain. So here's how to show this domain in interval notation. In words, it means any x value that is not equal to negative 5 halves. Let's look at a second example. Rational expressions with a single variable are functions. And so I went ahead and wrote this expression in function notation. Notice that the denominator is a trinomial, and we're going to approach this the same way. We're going to find where this trinomial equals 0. So we'll set this equal to 0. We'll solve for those x values, and then we'll exclude those x values from the domain. So what x values would make x squared minus 2x minus 15 equal 0? We can solve this quadratic equation by factoring. Let's factor this into two binomials. They each begin with x, and the numbers here multiply to negative 15 and add to negative 2. So I have x minus 5 times x plus 3 equals 0. By the zero product property, that means x minus 5 equals 0, or x plus 3 equals 0. So x equals 5, or x equals negative 3. Now again, these are the two values I do not want to include in my domain. So I can write the domain in a couple of ways. Here's one way to write it in set notation or set builder notation. I could write all the values x such that x is not equal to negative 3 or 5. This means all the real numbers except for negative 3 and 5. In interval notation, we imagine a number line beginning at negative infinity, working up to negative 3. But we can't include negative 3, so we skip over that number. And we go anything between negative 3 and 5 is allowed in the domain. We skip over 5, anything greater than 5 is allowed in the domain. So this is everything less than negative 3. This is everything between negative 3 and 5. This is everything larger than 5. And all of this together makes up the domain. This is the interval notation way of showing we exclude -3 and +5 from the domain. Finally, if rational expressions in a single variable are functions, we should be able to evaluate them in function notation. So let's evaluate f of -3 for this function on the board. I'm just plugging in -3 as the input value, and we're going to solve for the output. So f of -3 equals 8 minus -3 squared over -3 cubed minus -3 squared plus 4. Let's pay careful attention to positive and negative signs. This equals 8 minus 9 over -27 minus 9 plus 4. This is equal to -1 over -32, or +1 over 32. So when the input is -3, the output is 1 over 32. We evaluated this rational function just like any other function by plugging in our input value, simplifying and expressing the output value in simplest form.